Welcome to a new video which is about sandwich or squeeze theorem. I will show you the theorem and then solve 3 instructive questions regarding the topic. If this is your first time here and if you want to support this channel, don't forget to subscribe. Click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. Here guys, we have a theorem, and our theorem says suppose that we have 3 functions, f of x, h of x, and g of x, and they are all defined in set A. For every element in that set A, suppose that we have such a relation, okay? In our relation, this is a must. G of x is less than or equal to f of x, and that is also less than or equal to h of x. And also suppose that the limit when x goes to A, limit of g of x, which is the smallest function here, and the limit of, actually this has to be h of x. The second one is h of x, okay? So limit of h of x when x goes to A, and that is equal to L. And then we can say that limit when x goes to A, the same A here, x goes to A in both cases. And then when x goes to A, the same A, we can say that limit of f of x is also equal to the value of L. We have an example. And in the example it says in the square root of 4 minus 4x squared, and that is less than or equal to f of x, and that is also less than or equal to in the square root 4 minus x squared. And within this interval from -1 to +1, where the boundaries are included in our domain, what is the value of limit of f of x when x goes to 0, guys? If you look at the graph, okay, this is the graph of square root of 4 minus 4x squared and square root of 4 minus x squared. If you look at this graph, the red color represents square root of 4 minus x squared, and the blue color represents the square root of 4 minus 4x squared. And as you can see, within this interval from -1 to +1, the red color values are greater than the blue color values. This is the x-axis, this is positive x, and this is the negative x. And then we can say that this is the y value. For example, if you look at 0.8 at the blue color, and then we see that this is equal to this value, okay? But if you look at the function representing the red color, that is greater than the blue one. This is a must, in other words, that that function has to be greater than or equal to that function. And our function, which is f of x, in this case, should be between those two functions, okay? So this is the first condition that needs to be satisfied, as we see here. And then in the second condition, we can check that when x goes to A, here we're going to look at the smallest function and the highest function, the limit of those functions at the point x is equal to 0. This is our smallest function, right, which is g of x in our case. And this is the bigger function, which is h of x in our case. So let's take a look at limit when x goes to 0. What is value of square root of 4 minus 4x squared? We're going to just put 0 instead of x. That's all what we're going to do. So if you put 0 instead of x, then this is going to be 0, of course. And square root of 4 is going to left over, and that is going to be equal to 2, guys. And let's take a look at also limit when x goes to 0, the same value. Limit of the highest function, which is square root of 4 minus x squared, guys. Again, this is 4. If you put 0 instead of x, and then we're going to still have square root of 4, which is going to give us also 2, guys. That means because our function, okay, which is f of x, is between, as it is given us here, because it is between those two functions, and then we can say that limit when x goes to the same 0, that is extremely important, limit of f of x, it has to be equal to 2 as well. That is what we can infer from this theorem, guys. And let's take a look at our next question. Okay guys, we have another question, and in this question our lower and higher functions are different. The smaller function is 2 minus x squared divided by 4, as we see here, and the higher function is 2 minus x squared minus 2, guys. Within this interval from -1 to +1, the values that we're going to obtain from the right side will be greater than from the left side. Why? Because here the absolute value of x values are less than or equal to 1, so that is why we can say that this function, which is on the right, is greater than or equal to that function. So we don't have to look at the graph of this, we can easily see it from there. And now, because our function is between those two functions, okay, let's see what we're going to obtain by just evaluating the limits of those two functions at the point x is equal to 0. So let's say limit when x goes to 0, the limit of smallest function is 2 minus x squared divided by 4. And that is equal to, guys, if you put 0 instead of x, basically we're going to have 2 minus 0, which is 2, guys. And let's take a look at the limit of the biggest function in this question as well. When x goes to 0, limit of 2 minus x squared divided by 2, guys. And again, if you put 0 instead of x, still we're going to have 2 minus 0, which is 2, guys. So as you can see, the left limit is 2 and the right limit is 2 at the point x is equal to 0. So from this, by using this theorem, we can say that limit when x goes to 0, guys, limit of f of x is, of course, 2. Why? Because that f of x is between those two functions, and at the point x is equal to 0, they have limit as 2. That is why limit of f of x when x goes to 0 is also 2, guys. And let's take a look at our last question. And this is our last question, guys, in this video. And in this question, we have the smallest function is 2 times in the square root of x minus 1 minus 1, which is less than or equal to f of x, and that is also less than or equal to x squared minus 3x plus 2 divided by x minus 2. Our domain is from 1 to 3, including 1 and 3 points. So what is the limit of f of x when x goes to 2? And again, we will take a look at the limit of the smallest function and the highest function at the point x is equal to 2. If they are same, then we're going to say that limit of f of x when x goes to 2 is also the same as the others. So I put here also the graph of those two functions. This is the first one, 2 times the square root of x minus 1 minus 1. And this is our second function. And the red one is the highest function, okay, and as you can see, it has the values which are slightly bigger than the blue one within this interval from 1 to 3, guys. So let's take a look at the limit at the point x is equal to 2 for the smallest and the biggest functions, guys. Limit when x goes to 2, limit of 2 times in the square root x minus 1 minus 1 is equal to, guys. If you put 2 instead of x, then from here we're going to have 2 minus 1, which is 1. 1 comes out as 1. 2 times 1 is 2, so it's going to be 2. Minus, we have also 1 right here, so the result is going to be 1, guys. And let's take a look at the limit of our bigger function as well. Limit when x goes to 2. X squared minus 3x plus 2 divided by x minus 2, guys. And if you put 2 instead of x, let's see what we're going to have. 2 squared is going to be 4 minus 3 times 2, which is 6, plus 2 divided by 2 minus 2, guys. And that is equal to, guys, 4 plus 2 is going to be 6. 6 minus 6 is going to be 0. 0 divided by 0, which is an undefined condition. That means we need to find another way to solve this problem, guys. Well, there are 2 ways actually. You can solve this question into 2 ways at least. One way is you can just factor the numerator, okay? And then the second way is you can just apply the L'Hopital's rule, which means that you can take the derivative of the numerator divided by the derivative of the denominator. And then you can evaluate the function at the point x is equal to 2. But because taking the derivative is a little bit challenging, because some of you may not know already how to take the derivative. So I will solve the question in the first way, which is factoring way, okay? So if you factor x squared minus 3x plus 2, let's factor it here. X squared minus 3x plus 2, guys. You can just factor this positive 2 as a multiplication of 2 numbers. Let's say negative 2 times negative 1, right? If you add those numbers up, are we going to obtain negative 3? Yes. That means, guys, this number, which is x squared minus 3x plus 2, that expression can be written as x minus 2 times x minus 1, guys. So I'm going to write the leftover here, limit when x goes to 2, guys. Instead of x squared minus 3x plus 2, I'm going to write x minus 2 times x minus 1 divided by the denominator x minus 2, guys. And now, as you can see, I can cross out these values. These are gone. And the leftover is x minus 1. And now if you put 2 instead of x, then we're going to have 2 minus 1, which is 1, guys. And now because left limit, which is 1, guys, is equal to the right limit, and then we can say that, let me write it here, limit when x goes to 2, guys, f of x is also 1, guys. As you can see, the theorem is very easy to apply, but there are some certain conditions, like there should be such an order, and then we are going to look at the limits of the smallest function and the bigger function at the point A, and if we have the same limit, we can say that at the point same A, limit of f of x is going to be equal to the same limit, guys. Basically, this is the idea that we get from this theorem. That's it for this video, guys. If you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next videos.